With the maximum area and maximum volume problems, there's always going to be a parameter that we're maximizing. So we want to find the rectangle that maximizes the area when we're given 160 feet of fencing for a chicken pen. The function, the directions tell us to write it as a function of x, okay, where x is the width. So we want to write that statement down. We want to say let the width equal x. And then because the perimeter is equal to 2 x's, so x plus L, we know that 160, which is the amount of fencing that we're given, has to equal 2 times the length value plus 2 times the width. But since we're calling width x, we're going to write x instead of w. Now I have to solve this and get this as simple as possible in terms of L. So I'm going to subtract the 2x. And then to get L by itself, I'm going to divide by 2. So I divide all of these values by 2. And if you can simplify this part, then you should. And 160 divided by 2 is 80 minus x equals L. So I have 80 minus x equal to L. Now my area formula, okay, area equals length times width. And I've just found that my length is equal to 80 minus x. And my width we've already called as x. So this is area equals length times width, just written in the terms of the problem that we have. Now if you look at this and you multiply it out, then you know that you have 80x minus x squared, which if we're just going to sketch an area function, we know that this is a parabola because it's squared that opens down. So down here in my sketch, we're going to use a calculator, but not in this step. You're still just doing everything by hand. We want to label the x-intercepts and the axes. Well, x has already been called the width. Okay, so this is the width in feet. And the y value is area, and that will be in feet squared, or square feet, I'm sorry. And we have to figure out our x-intercepts. And we do that, we set the factors equal to 0 and solve. And we already have it factored. So we just say 80 minus x equals 0, and x equals 0. So my x-intercepts happen when x is 0 and when x is 80. And since this is a quadratic that opens down, I know that it's going to look something like this. That's not a very good sketch, but it's good enough. And the reason I made these dotted, okay, below the x-axis, is because if you notice, anything below this point here, this x-axis, is going to have a negative area, and that is not possible. So when we state the domain of the function, we're talking about the problem situation, which in this case means that it has to be between 0 and 80, okay, because anything on the outside of those parameters is going to give us a negative area, which we can't find. That's impossible. So the skinniest that this will ever be is a little bit past 0, and then 80. It has to be between 0 and 80. Now, to find parts D and E, we're going to use our calculator. So watch the next video and I'll go through all the calculator steps, but you should be able to get all of these parts without typing anything into your calculator.